thing, right? Now, I wonder what number that is, because I could probably skip a line or two.
6.
This is question 6, okay. Is it? No, okay. I'll try and skip a line. If it doesn't work, I'll fill in the other guys. Excuse me. We know this is going to break into 3 linear partial fractions.
Mm-hmm.
So what I'm doing right now is figuring out who the A, the B, and the C is. So I'm going to, if you've got your work in, I'm going to fill these guys in, and if it's the same as your guys, then I'll move on, and if it's not, then that's where the problem was, and then I'll figure it out the slow way. Okay, so that's going to be, I need a piece of scratch paper. Kind of shortcut you can use for these things. -12 over -6. So that one's 2. It's -5. 4 lots. 2 squared. Yikes. 2, 4, 16. 16. My shortcut's not any faster than that long way. -2 squared. 4, 4, 16. Add 14. Take away 12 is add 2, so that's 18 on the top. 2, 10 on the bottom. Does 9/5 look right? Did you get 9/5?
Yeah, for B?
Yeah.
Yes.
Okay. Right, let's do the last one then. So 3 squared, 7 lots of 3, take away 12. 3 times 5, that's 36. Take away 12. 15. I get 1/5 for the other one. Does that look
yes,
right?
Sir.
Okay. If you're wondering what that shortcut technique is, I'm not showing you because it distracts too many students, but it's called the cover-up method. Only works for linear, but if you want to look it up, you can. So anyway, this guy becomes 2 natural logs. This guy becomes 9/5 natural logs. The last guy becomes 1/5 natural log. So far, so good?
Yes, sir.
Now, when you do logs, we almost always ignore this, except today. Just now and again, you actually need the absolute value. So I'll show you what happens. Plug into 2 log 2, plug into 9/5 log 4, plug in 2. 2 take away 3 is -1. The natural log of -1 is no good, but the natural log of the positive one is, so that goes there. Take away, plug in 1, 2 log 1s, plug in 1, 9/5 log 3, plug in 1, can't get -2, that's why the absolute value is there, but you can get 2. And now, did you get that?
Yeah, and I know that the natural log of 1 is 0.
Great, so we can kill those 2 off. So I have 2 log 2s, 9/5 logs 4s, add a 9/5 log 3, add a 1/5 log 2. I guess there's some tidying up, but I'm not sure how much is worth it. If you add that guy to that guy, you get 11/5 log 2. And not really much you can do about 9/5 log 4 and 9/5 log 3. I guess I could call that 2 to the power of this, 4 to the power of this, 3 to the power of this, and multiply them together. If I did that, which I wouldn't want to, but if I did that.
Are they subtracting?
No, I'm adding. Oh, thank you. Thank you. So that there will actually become 9/5, and this will be a subtraction. Still messy. Be the log of 2 to the 9/5 times 4 to the 9/5. Are they all 9/5? Ah. Then pull out a 9/5 and go log 2, add log 4, take away. This is just combining logs, log 3. So if you take log 2, you'll add log 4, take away log 3. You can combine them. 2 times 4 is 8 divided by 3. And that would be the ultimate answer. At least that's as simple as I could get that. Which is the correct answer, actually. So I must have done it right. Was it somewhere in the log world or the negative bit that was getting the problem, do you think?
So and for B, I originally got 10 or 18/10, and I reduced the 18, but not the 10.
Oh, hey, not that I've ever made a mistake. Okay, what's the next one?
Could we do a problem where there's a quadratic factor in the denominator and you have to do the u sub at the end? Because I didn't know to do the u sub.
Okay. Can we imagine then that we did one and we got a 4x over x squared plus 4, right? Something like that, right?
Yeah.
So you got to that bit and I just said use u sub, so let's do the u sub. If you differentiate with respect to x, you get 2x. Crossover and isolate the dx. Well, this would become the integral of 4x over u times 1 over 2x. Cancel, 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 cancel. 2 over u. 2 natural logs of u. And then return to the axis.
All right, thank you.
I got into a
Yes.
situation where I had to do that to a fraction that had bx plus c above it.
Okay, so
and
what
that's-
you do
Yeah.
if you have something like that is you don't. In these questions, when you get that, you always separate each one of them as its own integral. And this fella is that. And this guy, we already know who he is. So that's how you tackle that problem.
Oh, okay. Thank you.
So you won't really work if you keep it together. I guess I should keep that here a little bit longer.
So for the one with the x, you would do a u sub, and then the one with the constant, you would just like take the integral of it.
Yeah, you do it as a standard integral. We now know how to integrate that guy. It's 1 over a, the inverse tan of x over a. So we use that whenever there's a number on the top. So if that was 7, I'd just say 7 of this. If that was 1, it would be 1 of this. this case it's 3, so it's 3 of this. Are we good? Good. So let's do a little bit more work and then move on to our last part. This is us still on section 7.4 partial fractions. This is a version of question 11. We have an e to the x, and then we have an e to the x take away 3, and then e to the 2x add 1 dx. So what you're going to have to do here is a u sub first. And say again?
E to the x.
Agreed. And that gets you the derivative e to the x. And the crossover is very nice. And when you isolate dx, it's not too ugly. I'm just going to leave everything for a minute. If you're not sure how a u sub's going to go, and you're not sure whether you should start turning everything into u's first, then don't. Just turn the dx into what it is. Because in this particular example, do you see that these two cancel out? And I'm taking this nice and slowly. Now, everybody has to be, everybody that's an x has to turn into a u. So let's see what this fella here becomes. What does this guy become?
Can I just put in the u's?
Yeah.
That'll be u to the squared. Sorry.
No, because that'll be one here. So this integral, which is pretty much useless, right? We can't do anything about it. Can you see how the u sub has converted it into the guy we're used to, right? A nice partial fraction. Is it okay for me to dot this, or you know?
I guess that was my question on whether when I break it up into the partial fractions, whether I should leave it as u or put ex back.
Leave it as u.
in. Okay.
Until you're finished, right? So when you're finished, you might have things like the log of u and a half inverse tan of u over 2 and stuff like that. And then once you've got the bit where the plus c would go, right? Then pretty much the last thing you do is turn it back into x's. So keep it as u's until you're finished.
Thank you.
As I'm saying, is it okay for me to dot that, or do you want me to go to the end?
Could you go to the end, please?
Right. So what we're going to do then is we're going to use partial fractions to figure out what this guy is. Now, this is the split. Are we comfortable with how this breaks into its baby fractions, its partial fractions? The u minus 3 term gets a single a above it, but the quadratic term gets 2, a bu plus c, right? A, b, c. Then what we do in this process is we take this guy and some brackets around everybody, this guy, and combine them into a single fraction. So you multiply this guy by What's it missing? It's missing a u squared plus 1. And you take this guy and you multiply it by what it's missing, in this case a u minus 3. And now you've got a lots of u squared plus 1, add bu, add c of u take away 3 over that. And then we basically say, look, since the bottoms are the same, so should the top. In this particular question, that leads to this expression. And now we enter the, in this case it's going to be the letter u, the choose u equals. Now I'm looking for a value of u that makes everything disappear except one letter. And there's only one value of u in this question that's going to do that job. So if we don't know how you pick that, that's going to be your first skill that you're going to try and encourage. What value of u would be useful first time round?
3.
Good. If you think of 3 going here, won't that entire thing disappear as a 0? So that's what I'm getting at. So we'll choose a 3. So it's going to be 3 squared plus 1, which is 10, plus a 0, and it's equal to 1. That makes a 1/10. And we got our first missing letter. What I suggest you do in these questions is the minute that you know what a is, rewrite it, but replace the a by a 10th. And a couple of reasons why you do it. First one, you really sort of have to if you want the thing to work. But the other one, it kind of helps you figure out who's still missing. Now it gets a little bit harder, but there's only one value of u that is going to help us this time. What value of u is, you're right, I was going to say what value of u kills off one of the letters, and 0 is the value of u that does that. So what does that get me? It gets me 1. It's equal to 1/10. U squared plus 1 is just 1. Plus, u makes that go away, so you're just going to have c. And 0 there gives you -3, so I have 1 equals 1/10. Subtract 3c. Subtract 1/10 from both sides. And I now know that c is -3/10. And every time you find a letter, you rewrite the original expression, but now replace c by -3/10. So we've got 1, it's equal to 1/10 this guy, plus bu add c is basically that guy, u minus 3. So you can see the a is a 10th and the c is -3/10. And now you come to the next guy. Now, as long as you don't pick 0 or 3, you're going to be fine here. So since there's only one variable missing, any choice of u, as long as it's 0 or not 0 or 3, will work. I know what one I'm picking. So here, try and be a mind reader. What u do you think I'm going to choose?
4.
I am. Why do you think I chose it? Since you're good at reading minds.
Because it makes the u minus 3 equal 1.
Well, 1 makes a u minus 3 negative 2, but no, I just don't want to calculate things if I don't need to. My favorite number would be 0. You know, if I could get to use that, I would. But if I can't use 0, I tend to use 1 or then 2. I keep it small. You know, I'm not going to use 87, right? It would work, actually. 87 would work. I just don't want to use big numbers. So it's 1/10. 1 squared plus 1 is 2. Added to bu just gets you b. Take away 3/10. And that take away that is negative 2. So that's 1 equals, I'm just going to keep it as tenths. I know that's 1/5, but I'm just going to keep it as tenths. That's negative 2b, and that's plus 6/10. So that's 8/10. And if you take away 8/10 from both sides, you get that line. And then if you divide, you get your last guy. So we now know the partial fractions. So this fella is going to be a over u take away 3 plus bu odd c over u squared plus 1 du. I know a is 1/10, so I get 1/10 u take away 3 du added to b is negative 1/10, so I'm going to call that negative 1/10 u squared plus 1. And if you notice that I'm separating it as we do it, and then I'm going to add negative 3/10 over that guy. Are you happy about this is A, this is B, and this is C, and that you always split them as 3 separate integrals? We're comfortable about that line? Yeah. If we're not, tell me. Okay. But this fella is going to be 1/10 the natural log of this fella. This guy at the end is going to be negative 3/10, the inverse tan of u. And what am I going to do about this ugly thing in the middle? How am I going to tackle that guy?
U sub.
U sub. Well, unfortunately, it's called U, but you're right, it is a U sub, so I'm going to have to call it a W sub, right? Can have the same variable both sides, it won't make sense. So I'll differentiate W with respect to U. I'll do the crossover. And I'll isolate. So this becomes negative 1/10 U over W times 1 over 2U dW. The U's cancel and the 2's, well, you got to be careful with that. Well, I get negative 1/5 or negative 1/20 when these two intents interact. Negative 1/5 or negative 1/20. What do you get?
1/20.
1/20th.
Well done. Yes. Which means it's negative 1/20 the log of W, which then becomes negative 1/20 the log of U squared plus 1, which goes in here, I guess. And you type that all in, And the darn WebAssign says you're wrong.
Switch back to EX.
Let's put the EXs back in. That's one big question. Any questions about that one? Lots of places for little pluses and minuses and twos to disappear on you.
I had a
So,
question.
yes.
I was wondering if there's any kind of like rule of thumb for like when you do U subs and when to convert the terms to U and when not to. Is there like,
You mean, how do we know this is a U sub, but I'm trying to
I
think of
mean,
one.
like how
But
do you
why
like
this
know?
one here isn't a U sub? And why this is?
No, I mean,
Yeah.
like for the problems that are U subs, like when you know to turn the terms into U's and when not to.
I think of what your question is. Guess it's too early in the morning for me. Are you asking how do I know what U sub it is, or are you asking how do I know when a U sub is what I should do?
I mean, like when you're like solving the problem, when to turn a term into U.
That sounds like when do you do U subs then? That's what it sounds like to me. So, if I had a question that looked like this, that would be a partial fraction. If I had a question that looked like that, that guy is a U sub. The most obvious thing to me is factor denominator. And just to make things really awkward, here are two questions that you do totally differently. This one ends up being a U sub, and I know that because when I differentiate that, I get a version at the top. This one, however, do you see it is now a partial fraction? I could take this question and rewrite it like that, and I could do partial fractions. So the answer is I could use both methods. But a U sub would take me 3 or 4 minutes, and that guy partial fractions always takes a lot longer because there's much more to do. So there isn't an easy, if you see this, then do that kind of rule. It's a little bit more of an art. I've seen so many of them in my life that I can look at a question. Now, your job is a lot easier because don't you only get partial fractions in partial fraction questions section, and you only get the U subs in a U sub section. So what your issue becomes more relevant when it's just an integral. Here, do this, right? And there's no indication of what method it would be. And that you just have to do through experience. Sometimes you do it by trial and error. You try a U sub and it doesn't work. And then you notice that you can do partial fractions and that does work. So I wish I had a better answer than that. But if that's your question, the short answer is no, there isn't a rule of thumb. It's more recognizing certain shapes to functions and what method would be used. Giving another example since we're on this. One of those is an integration by parts. The other one is a U-sub. Which one is the integration by parts?
The bottom one?
Nope. Now, they look very similar, right? What happens when you differentiate this guy? Don't you get a version of him? That's why this is a U-sub. If you differentiate him, you don't get anything that looks like him. That makes it not a U-sub. But if you're not a U-sub, and you're not an integral I just know the answer to, don't you have to be an integration by parts because it's the only guy in town? Now, there are no fractions there, so it can't be partial fractions, right? So suppose I give you a question with partial fractions in it. One of them is a partial fraction. One of those is a U-sub. I don't mind, I prefer people, tell me what they think rather than just saying, well, he's just going to say I'm wrong and I'm going to look dumb. You're not going to look dumb.
Isn't the bottom one going to be the partial fraction? Because you could take the x out.
Yeah, that would be, actually, that would probably make it even more obvious. What would the U-sub be in this top one then?
The whole denominator.
Yeah. Now, can you see things that might look the same or at least similar? Can't they use totally different techniques? Now, is there a rule of thumb for that? No. It's more of, if it was a U-sub, what would my U-sub be and would it work? And if you kind of think it through without actually physically doing it, if you can do that, you can say, hey, if I used x cubed plus 2x as a U-sub, wouldn't I eventually get a 3x squared plus 2? Does that look like the top? Not really. So it ain't a U-sub then. Okay, if it's not a U-sub, what else do I know? Well, integration by parts, not even a starter, right? I wouldn't even think about that as an option, right? Partial fractions then. So you kind of go through a little, your shopping list is getting bigger, right? The things you can pick from are getting larger, right? But they're still limited as well, right? You still only have a few things you can do. And I would look at that. Okay, now, continue with this section. It's asking you to find the area under a region, but that's just a shortcut for asking you to do this guy. What you gonna do? Because this is the first time we've seen this situation, although we have planned for it. It's the first time we've actually seen a question where you needed to do it. What do I need
Long
to do?
division.
Yeah. How do you know?
Because the degrees of the numerator and denominator are the same.
Right. So this is one of the two questions where you actually need to do long division. Okay. It's kind of, thankfully, it's a very simple long division. Would you agree that negative x squared turning into x squared only requires me to multiply by -1? And -1 times this guy is -4x, and -1 times this guy is positive x squared, and you do a subtraction. It's a bit messy, but that, take away that.
Wait, Professor,
5.
don't we need to have a placeholder? Because you
Yeah,
don't.
let's do that. So that, take away that, gone. Nothing, take away -4x is add 4x, and 5 take away nothing is 5. It means that this question now becomes -1, the quotient, plus a remainder, and I'll do that guy. You know, separate them out essentially. Now, how am I going to do this fella now? He might be a U sub, but it doesn't work. So what's my other choice?
Pull the x out in the denominator.
And if you pull the x out, do you see it's now a partial fraction question? That makes sense? And then you do the usual. Let's say that's probably one of the quicker ones, right? Because they're both linear, come out pretty quick, pretty fast.